Okay, hello everyone. Hello, dear instructor. Today wanted to show you my final project and CCP, and I wanted to start with its title, Intelligent Defense: a Machine Learning Approach to DDoS Attack Detection. Okay, let's start. I'm going to talk about a topic that's becoming more and more important in our digitally connected world, especially in cybersecurity, and more specifically, how we can use machine learning to detect DDoS attack. As we all know, all of them use online service like business, daily life, and keeping the service available and secure today is absolutely critical. But with dependency come a risk among the many cyber threats we face. DDoS, or distributed denial of service attack, are some of the most common attack used today from the hacker. A DDoS attack works by overwhelming a system like our website or server with a huge amount of traffic, making it crash or become unavailable to real user. This can cause serious problem from financial loss to damaged reputation and even potential data breach. Traditional defense like firewall and intrusion detection system do help, but attackers have gotten smarter. Modern DDoS attack can mimic normal traffic, making it really hard to tell what's real and what's malicious. That's where machine learning comes in. Unlike static defense, machine learning model can analyze massive amounts of data, recognize patterns, and adapt to new threats in real time. By learning from past attack data, this model can predict and flag unusual behavior that might signal a DDoS attack. Recent research shows us that machine learning, especially techniques like neural network, can achieve very high accuracy in detecting different kinds of DDoS attack, like HTTP flood and more. And as more devices connect to the internet, especially through the IoT or Internet of Things, the potential attack surface grows, making this research even more relevant. In this project, I built several machine learning models, including random forest, logistic regression, and neural network, to test how well they can detect DDoS attack. My goal was to understand which model perform best and how this technique can help better protect our digital infrastructure. Okay, now let's move to the backgrounds. Let me give you some backgrounds about DDoS. I think all of them know what is DDoS attack and how it works. In free word, DDoS attack or distributed denial of service is when hackers try to make website or server crash by sending too much traffic all at once. They use many hacked computer to do this, which make it hard to stop. The goal is to block real user from accessing the service and the system and the website and so on. Over time, this attack have become more advanced and harder to detect. A good example is the GitHub attack in 2018, which reached about 1.35 terabyte per second. It was one of the biggest ever recorded. So traditional security tools like firewall or system based on fixed rule often can't keep up with this new smarter attacks. They usually rely on known attack patterns, so they struggle with detecting new or changing methods. That's why machine learning now being used today to detect the attack. It can look at large amounts of network data, learn from it, and spot strange or harmful behavior, even if it's something new. Uh, and as quick words, we have three types of machine learning used for DDoS detection. First, the supervised learning, unsupervised learning, and hybrid model. Okay, let's move to the methodology that I used to build my machine learning model. The main goal it was to build machine learning model that can detect DDoS attack accurately. I followed a structured process that included collecting data, pre-processing the data, analyzing it, splitting it into training and training and test data. After that, I trained the model with three machine learning algorithms, that is random forest, logistic regression, neural network. After that, I evaluate the model using accuracy, phone score, precision, recall, and confusion metrics. And the last step, it was the classification on real data. All of this step is explained in details as we show. And now I wanted to start with data collection step. Okay, in this step, for this research, I used a publicly available dataset called application layer, that is DDoS dataset, which I found on Kaggle. It's a trusted platform for machine learning dataset. The dataset includes over than 66,000 records and 79 features related to network traffic, especially for detecting DDoS attack at the application layer. Each row in the dataset represents a traffic flow and includes important detail like flow duration, packet size, packet rates, enter arrival time, header length, and more. I built a table that describes some of the important features that is used in the data, like destination port, flow duration, flow packet, flow bytes, flow backwards packet, total length of FWD packets, and so on. And here's some of short description, like destination port is the number used in the traffic, duration in the traffic flow in microsecond, number of packets sent from the source to the destination. Total backwards packet is the number of packets sent from the destination to the source, and so on. That's total. The total data was split into two classes, label, benign, and DDoS. The benign is about 31,000 total records, and DDoS it's about 34,000 records. That indicate the data is balanced, and it's great because it helps to train the machine learning model more effective without needing more major adjustments. Okay, in data pre-processing, before training any machine learning model, it's very important to clean and prepare the data properly. Raw data often has problem like missing value, extra space, or no numeric value, which can affect how well the model learn. Here, what I did during the data pre-processing phase.